Hello, everybody. I'm Sanjay, your host for this session. Welcome to another exciting session here at TestMu Conference 2024. In today's session, we'll be exploring a crucial aspect of data management, automating data validation in file based target systems. Our speakers, Pranavi, Kandagadla, Prasad, and Manoj Kumar, Anand, bring a wealth of experience to this topic. Pranavi is a quality engineering manager with over 13 years of experience in delivering high quality software products through cutting edge testing methodologies. Manoj is a seasoned software quality assurance engineer with 10 years of experience in ETL, ELT, data warehouse, Salesforce, and SAP systems. In this session, Pranavi and Manoj will introduce a generic data validation framework that tackles common validation needs across different data pipelines. Built using native AWS services and available as a CDK, this framework leverages the data quality feature in AWS Glue to automate critical checks like null checks, file structure validation, valid value verification, and duplicate detection. The goal to simplify and automate data validation across various systems with ease. This session will be particularly beneficial if you're involved in managing complex data pipelines and looking to streamline data validation. After the presentation, we'll open up the floor for a Q&A, and so feel free to ask Manoj and Pranavi any questions that you have in the Q&A option to your right. So without any further ado, let's jump right in. Manoj and Pranavi, over to you.
Manoj, you wanna go ahead and
Yep,
share?
on my screen now. So
Yep.
I guess people can see the screen. Uh, yeah, hi all. Good morning, good afternoon, and good evening because I guess we have audience from all over the globe. Just a quick round of introduction. Pranavi, do you want to start?
Yep. First of all, thanks, Sanjay. You introduced us very well. But yeah, I'm Pranavi Prasad, and I currently work as one of the quality assurance managers on one of the teams here at AWS. And Manoj, over to you.
Yep. So I am a quality assurance engineer at AWS, and I work for Pranavi's team. We are part of a centralized QA group within AWS.
Yeah, I'm going to cover what we are going to cover today in today's session. We're going to cover all the challenges and complexities in data validation space in today's world, and of course, how our solution can solve these problems and prerequisites in order to implement our solution and solution overview itself, and a quick demo showcasing our solution in action and key takeaways and resources. Let's take a quick look at challenges we face today in data validation space. First up is data velocity and volume. As we all know, the speed at which we generate the data and the volumes of data in today's world, it's very hard to validate this humongous amounts of data efficiently and in timely manner. Traditional validation techniques will not scale and cause performance issues and delays in the data pipelines. Next up is variety of data. In modern days, we deal with large varieties of data coming from different sources and in different structures and format. And validating this data can be complex and time consuming. And next up is data validation itself. Data quality issues like missing values, format issues, duplicates, etc., can be very difficult to detect and resolve. And addressing data quality issues is essential and for ensuring data accuracy and reliability. Next up is monitoring and alarms. Implementing effective monitoring and alerting systems to promptly detect and respond to data validation issues at scale is a significant challenge. Manoj will be covering how our solution will help solve these challenges in next slides.
Thank you, Pranavi, for going over the slides. Before we move into our solution, I would like to touch base upon a key concept of CDK, which is how our framework is built on. CDK is essentially an open source software development framework which is designed by AWS, and it allows users to define and provision cloud infrastructure resources using programming languages like TypeScript, Python, Java, uh, and CDK provides a high-level declarative way of programming your infrastructure as code, and it helps to automate your deployment process. So just to simplify what a CDK represents, I have a very simple representation here. So as you can see here, uh, you have individual AWS resources. So in this case, in this example, we can see SQS, Lambda, S3, and DynamoDB. And these resources are grouped together based on the functionality. And grouping of these similar resources is uh, called a construct. And construct is something, it's a fundamental basic building block for a CDK. So you could have multiple constructs within a given infrastructure, and those constructs could be interacting with each other. And all of these created constructs can reside within a within a stack. So you can assume stack is like a logical separation of various functionalities, and within a given app, you could have multiple stacks as well. So you can see here all of the stacks, the constructs, and the resources are encapsulated within the app. So each of these app is then packaged and built using CloudFormation template. And these CloudFormation templates later translate your infrastructure as code to actual resources which are created in your AWS accounts. So your SQS, Lambda, S3, DynamoDB actually get translated to the resources themselves in your AWS account. So this is some of like the basic concept of what a CDK is. And now moving on, let's uh, move on to the solution here. So this is our solution overview. And like I mentioned, our solution is built on top of CDK. So the the box here, which you see, represents your AWS cloud infrastructure within a given AWS account. And as you can see, your the CDK has multiple components here in terms of AWS resources. And at the heart of it all, we have glue. So just to start with, let's start from the top of the framework ingestion. So we have an input S3 bucket. We have two lambdas here. One lambda is for the configurator lambda, and the other lambda is the glue invoker lambda. And the input to the framework requires two files. One is a config file, and the other is the data file itself, which needs to be validated. So the role of the config reader lambda is to read the config data which the user has provided and update the glue data quality. So the glue job has an inherent feature called data quality, which the framework is leveraging. So we did not want to reinvent the wheel here because glue itself is powerful and it has a built-in solution to monitor data quality issues. So our framework leverages this feature of glue uh, to perform data validations. So the essentially the config file will have all the rules which we need to validate against the data file. So the rules are being updated uh, by the config reader lambda, and the glue invoker lambda just triggers the glue job once there is a data file drop in the S3 bucket. And as you can see, everything in this framework is event driven. So the framework is built upon the concept of event driven architecture, where it does not require a human intervention during the execution of the validation. So the only input the user has to provide is the config file and the data file. And then everything starts off in an event driven fashion. So once the glue completes its data quality, evaluation, it posts its output onto another S3 bucket. And then we have another lambda which reads the output, understands what rules have passed, what rules have failed, and then publishes that data onto CloudWatch. CloudWatch is again a monitoring system from AWS, which lets you analyze logs and build dashboards. So we do have a CloudWatch dashboard where we can see the output of. And we also have an SNS email notification system, which notifies the user on process completion. So this is essentially a high-level architecture diagram of our framework. And moving on. So like I mentioned, the user needs to provide just two files for the entire process. One is the rule file and the other one is the data file. And the rule file, so I have a representation of how your config should look like. So if you can see here, the config is a JSON-like object, but it's not JSON, which requires the users to provide rules in a format which Glue understands. So, excuse me. So Glue has again a feature of built-in rules, and they have close to 20 plus built-in rules which can perform data validations as well as structural level validations uh, automatically. So as you can see here, I have provided a list of sample rules here. So you can see here, we are checking whether the column ID exists within a file. So the rule simply translates as column exists ID. And you do have, like I mentioned, we do have 20 plus built-in rules within the data quality evaluation system, which the users can leverage. The other input which the user should provide is the file format itself. And then we have another parameter called the sensitive data fields. So if we are working on a data set which includes PII data or some sensitive information, the framework has a provision to mask those sensitive fields. So if the user does not want to display those fields in the output, they can provide those sensitive fields here, and the framework also has the capability to mask those sensitive fields. So after providing the two files, since it's event driven, let's see how the output of the framework looks like. So I know the font on this slide is a little small, but we will have a demo of the execution where you can actually see how the reporting looks like. But this is a quick snapshot of what we can expect in terms of reporting for the framework. So as you can see here, this is a CloudWatch dashboard, which outputs the result of data quality evaluation, which we process. So we have a couple of widgets here. The first widget is just going to tell you how many rules have passed and how many rules have failed. The second widget is going to tell us the breakdown of the data, like how many records were processed within the file, how many passed and how many failed. And it also has a breakdown in terms of how many rules, what are the rules which failed. And the one of the most powerful part of this framework is that it isolates bad data. So user can quickly look at the bad records here and take corrective action. So this is a quick snapshot of how our output looks like. So I'm going to move ahead with the execution demo that we have recorded. So moving on. Cool. So as you can see here, I'm going to preview a Parquet file which is used. And usually you can, in large scale data processing, it's not just CSV, or it's sometimes we use Parquet files for compression needs. So Parquet files are sometimes hard to read. So we cannot directly view the contents of Parquet files. So for that, so in order to preview what we have within the Parquet file, I am using pandas package for Python to view the contents of the Parquet file here. So this is just to show you what the file has for our demo. So as you can see here, I am using a user data Parquet file, and it has certain columns like registration, date, time, first name, last name, email, standard customer data fields, which we would expect in any given file. So next, let's talk about the config file. So like I mentioned, the config file is like the first input that the user should provide, and it should be in a given format, like I explained earlier, and it leverages DQDL language, a data quality definition language, which Glue recognizes, and it is in the form of human readable and SQL-like and extremely easy to use, and they are built in, so you don't have to reinvent your own rules. So all the data validations which is typically performed on a given data set, you could leverage the existing rules built within Glue to make those validations. So I'm going to explain some of the rules that we have here. So in total, I have created 30 rules which will be validated against the data set, and these rules span across both the structure validation. When it comes to when I'm referring to structure validations, it mostly means whether we are checking if the column exists in that file, and the data type of those files, the column length of those files. All of these fall under structural checks, and the data checks are mostly what values do these columns have? Are these valid values? And is data integrity maintained within these data files, and do we have duplicates within those files? And all of these comprise uh, of the data validations. So let me just describe some of the rules that I have used here. So the highlighted rules here, we are just checking whether the columns that we need in the file are present. We are checking the uniqueness of certain column values within a file. So uniqueness of email equal to 1 indicates that we are checking the email column, and we are checking whether all the values within the email column are unique. And because that is one of the expectation, right? So we would want all of the customer data to have unique email addresses. And we are also checking whether the ID column is the primary key in the file. So next, moving on to certain data level validations, wherein we are checking if the first name has only literal string literals and not numbers. So we are using regex. So these rules support wildcard entries as well. So here I'm just checking whether the first name has only alphabets and no numbers. And I'm checking, sorry, moving back. Just a second. Yep. So here I'm checking whether the column value of gender has two values, male or female. So you can observe that these rules are extremely simple, and they're like SQL like. So you don't need specialized data validation skills to validate your data, because it's really plain English and SQL like. So you have keywords like in, where, which you can leverage for your rules. So the next rule here is that we are checking. Oh, I'm really sorry. Clicking on next is going to the next slide rather than pause and play. I should be a little careful. Yeah. Yeah. So you can see here, I am checking for completeness in the first name column value, and I'm also setting a threshold. I'm saying that 90% of first name should have values where salary field is greater than 50,000. So you could have like combination of multiple conditions to validate your data set based on your requirement. And it also supports custom SQL. So say, for example, out of those 20 plus rules that we have, the validation which you want to do does not fit into any of those built-in rules, you could write your own custom SQL. So, and as you can see here, I have written my own custom SQL saying that select count a star from primary where salary is less than 285,000. This essentially will return all the records as false for those records which have salary greater than 285,000. So as you can see, the rule set is extremely diverse, and it can be applied to most of your data and structural checks. And lastly, the two other parameters being used are file format and the sensitive data fields. In this case, I'm providing salary as the sensitive data field. Okay, so moving on. So like I mentioned, our framework is built on CDK. All of the resources will be deployed to your AWS account, and all of the resources and the underlying logic will be in the CloudFormation templates, which will then be later translated to your resources, and your resources will work as per the design. So I'm navigating to the CloudFormation template, which was created here. So as you can see, this is the CFT which got created by my CDK. And you can see all of the resources which have got created. So all the resources which I showed earlier have been created. You can see the input bucket. You can see IAM role permissions which are required for interacting with those resources. You have the Lambda function, which I showed you earlier, and you also have the glue job, which is like the core engine for this framework. And the data quality dashboard also exists there. So for the demo, as you know, our entry point to the framework is the input S3 bucket, where the user needs to provide two files. One is the config file, which contains the rules, and the other is the data file. So all the user has to do is just navigate to your CloudFormation template, click on the input S3 bucket, which was created by the CDK, and then you could navigate to the rules folder, and then just upload your rules file or your config file. Here I'm adding the config file, which I described a couple of slides ago. So as soon as the config file gets uploaded, the glue job uh, gets updated with the latest rules that the user has provided. And as step number 2, we will have to provide the data file, which needs to be validated. So I'm navigating to the data folder and uploading a Parquet file. In this case, I'm uploading the user data Parquet file, which needs to be validated against the 30 rules which we provided. So as soon as you upload the data file, we navigate to the glue job to see if the glue job has kicked off. And as you can see, without any human intervention, it has triggered because of the event-driven architecture. And you can see that as part of the argument list to the glue job, we have all the rules, the 30 rules which we described in the config file are all updated here. So this would typically take around 2.5 minutes for 1,000 records. And just skipping through the execution. Okay, so as soon as the glue job gets executed, we get an email notification because of the SNS feature there, just notifying the user saying that, hey, your glue evaluation is completed, data quality evaluation is completed, go to the dashboard and check out the results. So thanks to the CDK, we already have the dashboard created. And as you can see here, we have the data of the data quality evaluation populated in the dashboard visually. So you can see here, out of the 30 rules that we evaluated the data set against, we have 21 rules which have passed and 9 rules which have failed. And this gives us the record breakdown. So there were 1,000 records, 732 records passed the validation, 268 failed the validation. And the next set of breakdown, sorry again. Yep. Yep. So the next set of breakdown shows us the uh, rules which have specifically failed. Out of those 30 odd rules, you can see 9 rules have failed. So this just gives the user a snapshot of the rules that have failed. And in the next breakdown of the results, you can see exactly those failed records. So this is one of the biggest advantage of this framework, where you can actually isolate bad data very easily so that users can quickly analyze, debug, and then apply the fix that is needed to correct that data. So you can see 268 records have failed, and my failed record breakdown exactly has 268 records. And if you drill down a level deeper, you can actually see that data within your CloudWatch dashboard itself, the failed data. So in this rule, like I mentioned, it is failed because of the custom SQL which I had provided. And talking about the data masking capability, since we had marked salary as a sensitive data field, you can see that that particular value has been masked in the output. So this is really important when we are dealing with sensitive data sets. And I'm really sorry about this. Yeah. So talking about the failed rule here, you can see that salary is masked, and this particular record shows that it failed because the gender value is not male or female. And we can quickly look at the data itself to see if what is the value that the gender has. So it's currently blank. So that is why this particular rule failed. And we have another validation to check whether the comments field has less than 200 characters, because it's a string field. And let's just see what comment value has. So as you can see here, it has some junk data in comments, which you can easily capture and act upon to fix that particular data. So in this way, we are able to effectively gauge the data quality of a given file, and then uh, have a really nice visualization built around data quality issue, and get meaningful result out of those validations. So yeah, so moving on to the next slide, which talks about some of the key benefits of this framework. So approximately around 80 to 90% of data validations can be automated by leveraging this framework, because it already comes with preloaded 20 plus built-in rules which span across uh, data and structural validations. So this results in significant savings in manual validation hours, and increases testing velocity. Data validation itself is really complex, and we will need a lot of manual querying to analyze and identify bad data. So the framework precisely locates bad data and highlights the reason for failures. And this again decreases the time required to analyze our test results and to quickly isolate bad data. And the framework eliminates the need for traditional querying, which sometimes we testers do in order to scan through the data set and find issues. By leveraging this framework, obviously you can save humongous amount of effort and time. And since the CDK is completely takes care of all of the resource management, so we don't have to worry about connecting those resources or applying logic. All we have to worry is about applying those rules to those data sets. And the framework is extremely flexible and scalable, since we are leveraging serverless architecture and event-driven architecture. So some of the serverless components within the architecture are Lambda and Glue, and Glue is scalable and completely managed. So you don't have to worry about validating a huge data set. It's going to scale up and it's going to process the information as needed. And for just example runtimes here, in this particular demo, I showcased 1,000 record file validation that was completed in less than 2.5 minutes. You could go up to 1 million and 10 million. I have tested this for 10 million records and it took close to 15 minutes. I would say this is a really good runtime, because just imagine validating that 10 million data set manually. That would take hours. So, and the framework also includes data masking capability. It's so that we don't see PII data on the output layer of the framework. And the CDK also comes with a monitoring system, um, which tracks the health and performance of AWS resources itself. So this is done as part of achieving the operational excellence and to have visibility on the resources that are being used within the framework. So the framework also has CloudWatch alarms, just to notify the users in case of any resource failures or issues. And as an additional use case, we could leverage this framework as a continuous data quality monitoring system by plugging the framework directly to a data pipeline, wherein if the data pipeline outputs the file, our system kicks in, validates the data, and then just displays the output to the user, highlighting any data quality issues. Yeah, so these were some of the key takeaways. Yeah, finally, some resources for your consideration. To construct the rules, we need to be familiar with data quality definition languages, which are English and SQL-like built-in rules that Glue supports, and CDK itself, which is like the framework that we have used to build our system on, and Glue data quality, the feature which allows us to perform data quality evaluation. And just if you guys are curious to know how much usage all of these resources are going to cost us, there is a very interesting built-in facility that AWS provides, wherein you can monitor your resource usage by simulating the amount of, in this case, the amount of resource utilization that you would be needing for your data validation needs. So yeah, that concludes our presentation. Thank you for your time and this opportunity for us to showcase our framework. We are open for any questions.
Yes. Yeah. Sorry, it just took me a couple of seconds to jump back onto the stage. All right. So let me just first put up one of the questions that I noticed here, which comes from Mukesh. He asks, how does the data validation framework help in maintaining compliance with regulatory requirements such as GDPR or HIPAA?
Okay. So to start with, all of this framework is built in within your AWS account. So this was designed to help teams who have data residing in their AWS network And so if everything, if all the data that they are consuming lies within the AWS account, it's not going to go away. So our framework is designed to keep that data within your AWS account itself. So it's not going out of your AWS account. So I'm assuming that as data consumers, we should be mindful of all of these regulatory requirements. So we are not tampering with any of the regulatory compliances. Because we're not transforming the data, we are not altering the data, we are keeping the data as is.
Perfect. All right. Uh, on a similar note about the data validation framework, here's a question from Mahesh. How can the data validation framework be designed to handle real-time data streams without causing significant latency? Probably to rephrase, how can the data validation framework how can it be designed to basically handle real-time data streams without causing significant latency? Yeah.
Right, right. So this framework uh, should not be implemented in such a way that it can cause any bottlenecks in real-time data streams. So uh, the primary use case for this framework is for QAEs. So QAEs or PMs or even developers, right? So when they use this framework, what they're basically doing is checking the data quality of a data pipeline. So in terms of implementing this to a real-time data stream, right? We should not be implementing this in such a way that, okay, so if there is a failure, we are stopping the data stream. So that is not an ideal use case. So the ideal use case here is that we have a data pipeline and we want to monitor data quality. So we plug in the data pipeline and the data validation framework in a way that your data streams are not blocked, but they are read, evaluated, and projected uh, in a reporting way for so that users can take corrective action and the data streams are not getting blocked in the end. So that is how I would uh, place this framework in a real-time data stream.
Right. Perfect. Thanks, Manoj. One more question. Let's take one more question. This one is from Paul, and it's kind of to cover the other side of the coin as well, which is, are there any limitations to consider when using data validation frameworks, such as the one that you showed, when testing or training AI models?
So our framework is designed to have general data checks on a file-based target system. So when you're talking about AI models, right? So if the AI model is generating some data at the end of it and at the end of the process, we can plug in our framework, apply the rules that we feel are relevant to the use case, and then we can get the data quality evaluation at the end of it. So in terms of limitations, I would say that since this is restricted to a file-based validation system, we cannot have checks on this data which have external um, data dependencies. Say, for example, we have a file data coming in, and we have already consolidated like data coming in from multiple sources onto one single file, and we are validating that file system. But in this case, right, we cannot possibly join this file to an existing data sets in a database and then perform the validation. So this is isolated to that given file.
Right.
So you cannot use this framework for your ingestion or your in interim transformations. So this is considered as your final check. So we should be using this framework at the end of your data pipeline.
Right. Understood. All right. I think we do still have some time to take a few more questions. So
Okay.
I just wanted to pick up this one from Q&A, where the question is about, again, this is a question from Mahesh again. His concern is about privacy and confidentiality while validating sensitive data, right? How can a data validation framework be designed to ensure privacy and confidentiality while validating sensitive data?
Right. So as users, right? So if we need to validate on a given data set, we need to understand first: are we dealing with PII data? Are we dealing with sensitive data? And uh, in a given system, those information should be masked, and we should not be allowed to view that information. But in order to validate that sensitive data information itself, we need to understand like what fields holds that sensitive information. We can apply rules on those sensitive data fields, but at the end of the process, it will still validate that information, and it will not display that information.
Right,
So since the framework has data masking capabilities, we are already handling this scenario, wherein
right,
the users of the framework will not have visibility into what that PII information is. It will only have a masked value across those PII fields.
right. Got it. Let's close with two final questions, Manoj and Pranavi. Let me pick up this one really interesting question that I thought could, give a lot of insight to the attendees, which is what role does SQL play in supporting the framework's validation checks across different data pipelines?
So we need to have like basic knowledge of SQL. So without those rules, just imagine this scenario, right? You have a million records in that data set, and within that data set, you will have to uh, probably have like say 150 odd fields that you have to check. And just think about the test scenarios here. Like you have to check everything. You have to check whether each of those column exists, what are the valid values in each of those columns, what are the duplicate, are there any duplicates, are there distinct values. And if you understand the data better, there will be relation between one field and another field. So you will have to write SQL around those validations. So doing this manually is completely exhaustive and time consuming. To build those rules, right? So we need to have some minimum amount of SQL knowledge, like I mentioned, and like I showcased the rules, right? You have SQL like rules, wherein we are providing a rule like column X is in these values. So you have SQL like syntaxes, but not exactly SQL. So anyone without the SQL knowledge can also understand those rules. I would say if we have to leverage those built-in rules, we need to have some amount of SQL knowledge.
Right, right, makes sense. I want to thank Olga for that question. And finally, I just wanted to close with this question from Mr. Rana, which I think is quite overarching for the discussion that we had, which is what are the essential components of a data framework, in your opinion, in your expert opinion?
Uh, so some of the main components of a given data framework can be like, so the first thing is that you need to have a rule engine. So in this case, in our framework, Glue already has a rule engine in the form of data quality feature. So that is one of the most essential component for a data framework, because without those rules, you wouldn't be able to create a framework itself. You can think about million ways of ingesting data into your framework, have beautiful dashboards created at the end of the framework, but the heart of the framework is the engine, which is the rule engine. In this case, Glue data quality is the heart of my framework.
Right. Perfect. So yeah, thank you so much, Manoj. I think this was a really, really insightful session. Thank you, Manoj and Pranavi. Thank you so much for for that session. Your demonstration of automating data validation using AWS services was incredibly valuable, and I'm sure it'll help many of us enhance our data management processes. A quick reminder to all attendees, this session, along with the others, has been recorded and will be available on Lambda Test's YouTube channel. Be sure to revisit it and share the knowledge with your colleagues. Have a fantastic day ahead and stay tuned for more enlightening sessions. Thanks, Manoj. Thanks, Pranavi.
Thank you, Lambda Test. Bye.